Hello everyone. Today I am going to explain how to calculate the number of screw and dowels required for press tool. Before going to start calculation, we must know there are two types of force developed during shearing operation: vertical force and horizontal force. Here, see in the figure, force developed in the shearing operation can be represented by a triangle. Vertical shearing force is represented by V and horizontal force is represented by H. And in other figure, sheet thickness is represented by T and clearance is shown by C. Both triangles are similar. Hence, in vertical force calculation, sheet thickness must be considered along with the shear strength and cutting length of material. And in horizontal force calculation, die clearance percentage will consider. Means horizontal force is equal to vertical force into die clearance percentage. Vertical force. Vertical force V depends upon the shear strength of the material to be cut and the area to be sheared. Shear strength means shear strength is the strength of a material against the structural failure. So, V is equal to C into T into Fs, where V is equal to vertical shearing force, C is equal to cut length, T is equal to sheet thickness, and Fs shear strength of material to be cut. Now, with the example, it will be more clear. Find the force required to shear a dia 35 mm hole in a 3 mm thick MS sheet. Here, cut length is equal to 3.14 into 35 is equal to 109.9 mm, and we know V is equal to C into T into Fs. Now 109.9 mm into 3 mm into 400 is equal to 131,880 Newton. We know that shear strength of MS is 400 Newton per millimeter square, and 1 ton is equal to 9806.65 Newton. So 131,880 divided by 9806.65 is equal to 13.44 ton. So, the force required to shear a dia 35 mm hole in a 3 mm sheet thickness is 13.44 ton. Horizontal force. As we know, horizontal force H depends upon the die clearance. Die clearance, gap between the punch and die. Die clearance depend upon the work material. Horizontal force can be calculated by vertical force percentage because it is taken same as the die clearance percentage per side. Excessive clearance increased the horizontal force and increased tensile bar on the blank. For example, find the horizontal force required to shear a 35 dia hole in a 3 thick MS sheet. Here, vertical force is equal to 13.44 ton as calculated earlier. We know die clearance is equal to 2.5 to 5% for mild steel and convert 13.44 ton in Newton. It comes 131,880 Newton. So, horizontal force is equal to 2.5% of 131,880 Newton is equal to 3297 Newton. So, horizontal force required to shear a 35 dia hole in a 3 thick MS sheet is equal to 3297 Newton. Screw and dowels. Allen screw. Allen screw used for fastening the die or punch. So, Allen screw must resist during operation when stripping force generated. Stripping force can be taken as 10% of vertical shearing force. Shape load on screw threads with permissible stress is 80 Newton per millimeter square. For this, we have to calculate core area by the formula. Core area is equal to 0.7854 into D minus 1.227 P square, where D is equal to outside dia of threads and P is equal to pitch of thread. Here you can see in the figure DC is core dia, DP pitch dia and DO outer dia. Dowel pin. Dowel pins are used for positioning of the component. Developed to shear stress due to horizontal force resulting from die clearance. Dowels are rarely stressed beyond 50 to 80 Newton per millimeter square. Now, taking one example. A press tool is subjected to 40 tons vertical force and has got 5% die clearance per side. If the stripping load is 10% of the vertical force, find the number and size of the screw and dowel necessary. Here, stripping load is equal to 0.10 into 40 into 9807, because 1 ton is equal to 9806.65 Newton. Here vertical force is 40 tons and stripping load is 10% of vertical force. So here it's come 39228 Newton. Now root area of screw is equal to 0.7854 into d minus 1.227 p square. If we take M12 screw, then M12 screw having 1.75 pitch. So, root area is equal to 0.7854 into 12 minus 1.227 into 1.75 square is equal to 76.24 millimeter square. Load capacity is equal to 76.24 into 80 is equal to 6099 Newton. Okay. So, number of screw is equal to stripping load divided by load capacity. Stripping load is 39228 Newton divided by 6099 Newton is equal to 6.43. So, we can use 6 screw for M12 size. If we take M16 screw having 2 mm pitch, then root area is equal to 0.7854 into 16 minus 1.227 into 2 square is equal to 144.12. So, load capacity is equal to 144.12 into 80 is equal to 1153 Newton. So, number of screw is equal to stripping load divided by load capacity is equal to 39228 Newton divided by 11530 Newton is equal to 3.14. So, we can use 4 screw of M16 size. Vertical force V is equal to 40 into 9806.65 Newton and horizontal force is equal to 5% of 39266 because die clearance is 5%. So it comes 19613 Newton. If two dowels are used, then load per dowel is equal to 19613 divided by 2 is equal to 9807 Newton. At 50 Newton per millimeter square stress, area is equal to 9807 divided by 50 is equal to 196.1 millimeter square. Then dia of dowel is equal to square root of 196.1 divided by 0.7854. It comes approximate 15.9. So, dia 16 dowel can be used. If 12 dia dowels are used, then area per dowel is equal to 0.7854 into 12 square is equal to 113.1 millimeter square. Number of dowels at 50 Newton per millimeter square stress is equal to 19928 divided by 50 into 113.1. It comes 3.52. So we can take 4 numbers of dowels. As area of dowel varies according to square of dowels dia, it is better to use 2 big dowels instead of number of smaller dowels. I think you all have understood the topic. Thank you and take care.